Hello, welcome back to Chapter 13, Section 4. I'm going to be doing the guided practice problems. In the textbook, they're on page 953. I believe the PDF is page 30. And these are going to be just like the homework problems and the problems you're going to be seeing on the assessments. So in this first set, the directions say find all possible values of each expression. Now, I'm going to include one thing that Dr. Berger didn't include. I want you to give me the answers in degrees and radians, just because it's good practice. And actually, in the next step, it actually says that. So we're going to use our unit circle for these. I have sine inverse of negative 1/2. So on the unit circle, we need to figure out where the y value is negative 1/2. Anything above the x-axis, the y's are positive, so now I'm going to go below. So my two choices, or my two places are going to, they're not choices, but my two places is going to be, here's my y is negative 1/2, and here's my other y is negative 1/2. So it doesn't matter which one you write first. I'll do this one first. In radians, it's going to be 7 pi over 6, and I need to include all of the terms. So if I go a complete turn for a complete angle of rotation, that's 2 pi. And the n tells me how many times I turn. If n is 0, then I just get 7 pi over 6. If n is 1, that's 7 pi over 6. I go to 7 pi over 6, and then I take one turn. The n tells me how many turns that I take. In degrees, that same angle in degrees is 210. So that'd be 210 degrees plus 360 in. So that takes care of that side. Now let's talk about this side. Here's where the y value is negative 1/2 again at 11 pi over 6. So the other one is 11 pi over 6 plus 2 pi in. And that same answer in degrees is 330 degrees plus 360. I started to write 2 pi in again. Forgot I was in degrees. So I know it looks like I got 4 answers, but really I don't. I just gave the answer in radians and I gave the answer in degrees. These two and these two are the same. These aren't the same as those. These two are the same, these two are the same. And I've only got 2 places on the unit circle where that works. I just have to account for the fact that I've got an infinite number of angles of rotation. All right, what about tangent is going to be positive square root of 3 over 3. Okay, so again, I'm using a unit circle where I didn't write the tangents down. This is another example where it'd be great if you did. So just keep in mind, square root of 3 over 3 came from rationalizing 1 over square root of 3. So I'm looking for where the y has a 1 and the x has a square root of 3. That's right here. The y is 1 over 2 and the x is square root of 3 over 2. The 2's are going to reduce and I just get 1 over square root of 3. So my first place is going to be pi over 6. Of course, with all the angles of rotation that are coterminal. Pi over 6 is also known as 30 degrees. Now the other place is not here, because 1 over negative square root of 3 is going to be negative. It's also not here because a negative divided by a positive is negative. It's going to be down here. Negative divided by a negative is going to give me a positive. So in radians, I got 7 pi over 6. And in degrees, I got 210 degrees. And last one for this example, where does cosine give me negative square root of 2 over 2? So I'm looking for negative x values. That's on the left side. So here's the first one, at 3 pi over 4, also known as 135 degrees. 3 pi over 4 and 135 degrees. Again, these are the same. This is just radians and this is in degrees. The other place is right here at 5 pi over 4, which is known as 225 degrees. Write that down before I forget it. So again, just in summary, for the sine, cosine, and tangent, there's going to be two distinct places on the unit circle that are going to, two distinct angles of rotation that are going to have that x, that y, or that y divided by the x. And then you're going to, if it's radians, add 2 pi in. If it's in degrees, add 360 in. All right, we'll see you in the next video.